Hello students, welcome to Distance Learning with Nipendra Acharya. In this video we are going to learn about sequence and series, and this topic sounds familiar to you because you have already studied on class 9, and the playing field will be difficult and different than class 9, and but the knowledge whatever you have attained from grade 9 will be very useful and helpful to you. Uh, let's start our chapter. Grade 9 sequence and series, and this is the part 1, and it is divided uh, on 7 parts to make the video short and very much effective, so that you can search whatever you need uh, in a quick time. So you must not go through the long video. Quick revision on sequence and series, and revision is done on a different way. The question will be asked, and with the answer, each and every answer, you will revise, you will recall whatever you have studied on grade 9. So in a the revision is on question answer format. Okay, let's start. You can see on your screen. Let us consider few arrangement of number. You can see the arrangement of number on your screen. One, 4, 9, 16, and 20. It's the first arrangement of number, and second arrangement you can see 1, 5, 7, 8, 10, dot dot dot, and and read the question carefully or listen the question carefully and uh, guess the answer. First question, you can see on your screen, what will be next term on arrangement A? Can you guess the answer? Okay, guess the answer. And if you have whatever is your guess, and you can see the answer, is it correct or not? The answer is 36. The next term after 25 will be 36 on the arrangement A. Now we are building towards uh, something special, something very useful. What will be the next term on arrangement B? Now you have to guess the next term on arrangement B. The arrangement you can see 1, 5, 7, 8, and 10. What will be the next term? As you have easily guessed the next term on the arrangement A, as it is 36, then what will be the next term on the arrangement B? Now if you have an answer, then just check it out, is it correct or not with this answer. Now there is a twist. It can be any number. We exactly cannot figure it out. You may have guessed a number, isn't it? You may have guessed a number, but that number is correct. That number is correct or not. We can we cannot exactly figure it out because there is a reason, and we will come to that reason also. It can be any number. We exactly cannot figure it out. Why? There must be a question. Why we were able to find the next uh, term or number on the first arrangement, and why we weren't able to find the term or number on the arrangement B. There must be a reason, and there must be a question from a student, and any doubt of a student will be clear on coming question. What's the catch? And what's the catch means what's the difficulty? Why we weren't able to find the next number? As in A and arrangement A, we easily found the next term on the number on the arrangement as 36, but we weren't able to find the next number on the arrangement. And what's the difficulty? What's the catch? Catch means difficulty or hidden difficulty. And you can see the region. The region may be the number are arranged randomly without any fixed rule. Now, this is the difficulty, isn't it? This is the catch. The difficulty is the number are arranged without any rule, and we weren't very much aware about the rule. Now, let's see the another question. Did we follow any rule while finding 36 as the next number on arrangement A? Did we follow that rule? And what rule we are talking about? Does number on arrangement A done by fixed rule? And our answer must be S. Oh, S. They are. The number are arranged on a fixed rule. Okay, let's discuss about the rule. What is the rule then? There must be some rule, isn't it? That's why we were able to find the next term after 25 on arrangement A. And, and there must be a fixed rule, because as arrangement B is not done according to the fixed rule, that's the reason we weren't able to find the next term after a 10 on arrangement B. Now, what is the rule? Let's see the rule by which the arrangement A is done. 1 equal to 1 is square, 4 equal to 2 is square, 9 equal to 3 is square, 16 is equal to 4 square, 25 is equal to 5 is square. So the next term will be 36, that is 6 is square, and next term we are getting, isn't it? We are getting the rule. They are the square of a natural numbers, isn't it? The first term is the square of 1, second term is the square of 2, third term is the square of 3, fourth term is the square of 4, fifth term is the square of 5, and sixth term will be square of 6, and seventh term will be square of 7. And there is a rule. The next term will be 20. Next term will be 49 is equal to 7 is square, and so on. It goes by the rule. And let's see the rule. Then rule is they are square of natural numbers. Now, there was a rule. That's the reason we were able to find next term on arrangement A. And there was no rule. You can see the arrangement B. We can revisit the arrangement B. The gap between the first two terms is 4, and the gap between the second and third is 2. Gap between third and fourth is 1, and gap between again fourth and fifth is 2. So we there is no any rule, and there is no any sequence on the arrangement, there is no any pattern, or there is no any fixed set of rule by which the numbers are arranged. They are just randomly uh, placed number. They are just randomly grouped number. That's the reason we weren't able to find the next term after 10 on arrangement B. So the fixed rule is needed on the arrangement. Let's see the next question. What can we call arrangement A? What can we call? You can answer this question. What is the arrangement A? The answer is we call it sequence of numbers. That's the sequence, isn't it? We are studying sequence and series, and we now know exactly what sequence means. Sequence means arrangement of numbers on a fixed rule. Any arrangement are not sequence. All arrangement are not sequence. Only those arrangement are called sequence which are done by a fixed rule. If arrangement is done by a fixed rule, then only that arrangement is called sequence. Now both look same. They both look fairly same. They are both arrangement A and B fairly look same. Both are arrangement of numbers, but A is a sequence, B is not a sequence, because to be a sequence, there must be a fixed rule. Number must be grouped or arranged on a fixed rule. There must be fixed rule. Their fixed rule must be followed throughout. the arrangement. Now, arrangement A is a sequence, but arrangement B is not a sequence. So I think it's clear to you. Now there is another question. Can you list me criterions for any arrangement to be sequence? Now the criteria for any arrangement to be sequence, you can see there must be a certain criteria to be a sequence, as we already knew that all arrangement are not sequence. There must be a certain criteria, there must be a certain terms and condition needed for any arrangement to be sequence. Let's see the criteria. Of course, yes, the criteria are: arrangement must be done by fixed rule, and terms or members or element. These are terms. You can say terms 1, 4, 9. They are terms or members, or arrangement must be separated by comma. They must be separated by comma. If they are separated by comma, and then if the arrangement is done on a fixed rule, then we can call this arrangement a sequence. Now I think it's clear what is sequence is. Now let's move to another question. Still we have more to discuss. Now question. Well then, you can see, well then give me a complete definition of sequence. The answer, definition of sequence, you can note on your note copy. If the group of numbers are arranged on a fixed rule, okay, if a group of numbers are arranged on a fixed rule and separated by comma, they must be arranged by a fixed rule and must be separated by comma, then such arrangement is called sequence. Now it's a very easy definition, and you can see the next question on your screen. What is series then? Now uh, we have we have understood what sequence means. It's very clear to you. Then what series then? Now you can see the answer. You can see the answer. If the group of numbers are arranged on a fixed rule and connected or joined by an operator plus and minus only, there are four operators: plus, minus, divide, and multiply. We are only talking about plus and minus. If they are separated by plus and minus, then such arrangement is called series. Now you can see it looks similar also, but there is a difference between sequence and series. We will discuss it on the next slide. uh, it looks same, but only in sequence it is separated by comma, and here it is connected, or they are associated with operators. Terms are associated, the numbers which are, you can say the series is just a sequence of numbers, but the terms are separated by operators. It's also a sequence. The series also a sequence, but the terms here are not separated by comma. Here they are associated, or they are connected, or they are joined by uh, operator plus and minus only. Now let's see the example series. Now they are connected, or they are joined by plus sign, isn't it? It is an infinite series. Now there is another question. You can see the question. Sequence and series look similar, isn't it? Yeah, they look similar. Yes, but there is difference between sequence and series. They look similar, but there is difference. There is certain difference between them. Okay, then tell me the difference also. You can see the difference on next slide. Okay, let's discuss about the difference. I think it's clear what is sequence, what is series, and you have the example for series also. And the example for sequence is that the arrangement A is the example. You can copy that example. And let's see the difference between sequence and series. It's very important also. It may be actually in your examination. let's do the difference on a pictorial way. Now, there is a character, and the character is hello, I am a sequence. The character is sequence. He has pronounced himself as a sequence. And let's see, there is another character, and hey, I am series. He has pronounced himself, he has introduced himself as a series. Now we are going to find out the difference between sequence and series. What is the difference between these two characters? Now, it's the definition. If the group of numbers are arranged on a fixed rule and separated by the comma, then such arrangement is called sequence, isn't it? We know that. And you can see what series says. If the terms of any sequence are combined by operator. Now, this is the easiest definition for this series, isn't it? There is another definition in the previous slide that you saw a different definition. Here it is a different definition. Whichever you like, you can use. Now, another difference. You can see example. Uh, it's 2, 4, 6, 8, and 10. Dot, dot, dot. And another difference is you can do on your copy on a table form in 2 columns, sequence and series. 2, 4, 6, 8, and 10. Now this is the difference between sequence and series. It's a new thing, arithmetic sequence, series, and progression. And now there is a difference between sequence and progression. Let's see the difference. The difference between progression and a sequence is that progression has a specific formula to calculate nth term, whereas sequence can be based on a logic rule. We have found the general term of a sequence in class 9 by 3 ways. One, by checking whether the terms are linear sequence, quadratic sequence, or we did some question. We found Tn of some sequence by applying logic, isn't it? Now, so but in progression, it has a fixed or specific formula to calculate nth term. So any sequence having this specific or fixed formula to calculate uh, nth term is called progression. In progression, nth term is always calculated by a fixed formula, a specific formula, a defined formula. But in sequence, sometimes we use logic, sometimes we use the concept of a linear or quadratic. We did in a different way. So understand what sequence means and what progression means. And now, next slide. Let's consider a general sequence. The general sequence will be shown on your screen as T1, T2, T3, T4, T5, and gap on few terms Tn minus 1. This is the second last term, and Tn, and that's the last term for this sequence only. Now, that difference between the first two terms is T2 minus T1, and difference between the second and third is T3 minus T2. The difference between the fourth and the third is T4 minus T3, and T5 minus T4. And similarly, if we go to the last two terms, then the difference will be Tn minus Tn minus 1. Now that is, as we studied in class 9, is a first difference, isn't it? We have studied this. If the sequence is a linear sequence, then their first difference will be equal. We studied in that way. Okay, now let's. Now, what does it mean? In any sequence, if the first difference is equal or a constant, if they are constant, means if all these first difference T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4 represent us are equal, or they are constant, they represent a single value, constant value. If the first difference is equal, you can say then such a sequence is called arithmetic sequence. Now we are onto the arithmetic sequence, and what is arithmetic sequence? To be arithmetic sequence, the first difference between the terms must be equal or constant. must be same, isn't it? Must be a same value. T2 minus T1 must be equal to T3 minus T2, must be equal to T4 minus T3, must be equal to T5 minus T4, and must be equal to Tn minus Tn minus 1. If they are constant, if they are equal, then we can call that such sequence or series as arithmetic sequence or arithmetic series. And now let's see that equal or constant first difference. That equal or constant first difference is called common difference. We call it now in class 10 a common difference. In class 9 we called it a first difference and we represented it by a. If you have forgotten, then recall it. It was represented as a. We call the first difference as a and second difference in a quadratic sequence as 2a. But here in class 10, we are, as I have already told, that the playing field will be difficult and will be different than class 9. That equal or constant first difference is called common difference. What is the common difference? It is a difference between the terms and which is equal, which is constant throughout the sequence. The common difference, the difference must be same. The difference between T2 minus T1 must be D, T3 minus T2 must be D, T4 minus T3 must be D, T5 minus T4 also must be D, and Tn minus Tn minus 1 must also be D. It must be equal and we call it common difference, and which is represented by small d. Let's see the example. 5, 9, 13, 17, 21. Where difference between the conjugative terms is 4, that is d is equal to 4, isn't it? Yes, the difference between the conjugative terms is exactly 4. You can see here the difference between these two terms is 4. The difference between 9 and 13 is also 4. It is constant throughout the 4 and 4. It is constant throughout the sequence. So we can call this sequence, this entire sequence, as arithmetic sequence. I think it is clear for any sequence to be arithmetic sequence, the common difference between the terms must be constant or equal. Now finally we have found one formula, that is F1. You can see the formula will be shown throughout the exercise example wherever it is necessary. Now we have found our first formula on sequencing series. There are many formulas, and our first formula F1 is D is equal to T2 minus T1, or you can say T3 minus T2 also, or you can say T4 minus T3 also, whatever you call. Tn minus 1 also, it is the formula to find the D. I think, hope you understood, and you can pause the video, you can note it down, and let's move to another video, another slide actually. It's the example 1, and example says, is the given sequence an arithmetic sequence? Okay, it's a sequence. Definitely it is a sequence. It has a fixed rule. And is it arithmetic sequence? We have to check. Okay, there are arithmetic sequence, geometric sequence, harmonic sequence also, HM also. But we are only going to study in class 10 only two arithmetic sequence and geometric sequence. And is it arithmetic sequence? The question is asked as solution. Here, let's see, first term is 18, second term is 15, third term is 12, fourth term is 9, fifth term is 6, sixth term is 3. Now the difference between first two terms, T2 minus T1, is equal to 15 minus 18 is minus 3. Is it? Now the difference between first two terms is minus 3. Let's see the difference between third and second term, that is 12 minus is also minus 3. And let's see the another difference between 4 and 3 term, fourth term and third term, 9 minus 12, that is also minus 3. And we are going well. T5 minus T4 is equal to 6 minus 9, that is also minus 3. And T6 minus T5, 3 minus 6, that is also minus 3. So what we can conclude is that's D, isn't it? That's the constant. The common difference between the term conjugative terms is constant or equal. We can say the given series, hence the given sequence. In fact, sequence is arithmetic sequence. As the criteria to be an arithmetic sequence is true, we can call the given sequence as arithmetic sequence. And now this is very easy question, introductory question, actually a beginner's question you can say. Now let's move to another. Now we have a formula one. You can see the formula one throughout the video. And first formula, d is equal to t2 minus t1. Only we have derived one formula right now. We have found one formula, or we came across only one formula, and formula one will get populated as the video progresses. Now there is a question, important question. 7, x, 11 are the terms of an arithmetic sequence. Then find the value of x. Now there are three terms, t1, t2, and t3. Let's see how the solution is obtained. Here, let's note it down. T1 equal to 7, t2 is equal to 8, and t3 is equal to 11. Now we can find the common difference between consecutive terms, as we can see on our formula one. Common difference, d is equal to t2 minus t1. That's the formula. X is the second term. You can see x is the second term, and 7 is our first term. So our formula is 7 minus our formula is t2 minus t1, and x minus 7 is the value. Now as we know, the formula doesn't limit here. It is not exactly this. It also has t3 minus t2 part, isn't it? T3 minus t2 also is our formula. So we can apply this also, t3 minus t2. Again, that's the equation 1. Again, common difference, d is equal to t3 minus t2. This is also the formula to find the common difference, isn't it? T3 minus t2 is also the formula. T2 minus t1 is also the formula. Now t3 is 11 and t2 is x. Now this is the equation 2. From 1 and 2, because both equation we can equate them because they both relate to d. These two values both relate to d, so we can equate them. X minus 7 will be equal to 11 minus 8, and like term will be on same side. X plus x will be 11 plus 7, or 2x is equal to 18, and x is equal to 18 by 2, and we can cancel it. 2 1 is 2, now 2 9 is 18, so therefore the value of x is equal to 9. Now there is a note for you. This question can be done by another method also. There is another method, but not on this video. You have to wait for next video, second video. And as there are 7 parts, in the part 2 there is this question is solved there by a different way. Now let's move to another example. A formula 1, you can see formula 1. Example 3. A similar sort of question are the terms of an arithmetic sequence, then find the value of x. Very same. I think the two questions are very same. Solution here, t1 equal to 2x plus 1. The first term is 2x plus 1. This is t1, and you can see t2, and third term is t3. Now we follow the same procedure, same way. We have a common difference, d is equal to t2 minus t1, which is equal to 2x. The first t2 is, you can see t2 is 2x minus 1, and as there is a minus sign, we have to use bracket and write t1. Now let's open the bracket. 2x minus 1, you can see 2x minus 1 minus, and minus changes the sign. This sign is changed because of the minus present right here. Now sign is changed, we can cancel this, isn't it? You can see it is cancelled, and minus 1 and minus 1, which is minus 2, and this is equation 1. And again we can find the common difference isn't it? That is common difference which we can add here t3 minus t2 also. Now let's apply this t3 minus t2 common difference, that is t3 minus t2. The value of t3 is 3x plus 4 minus sign, and we have to use bracket 2x minus 1. While opening the bracket, the sign is changed because of this sign. Minus into minus is plus. Now we can subtract 3x minus 2x, that is x, and we can add 4 plus 1, that is 5. That is 5. Now this is equation 2, and from 1 and 2 both relate to d, isn't it? They both relate to d. We can equate them from 1 and 2. From 1 and 2, x plus 5, isn't it? Minus 2 is equal to x plus 5, and we can equate this part and this part, and like term are on same side, and minus 7 is equal to x. The value of 7 is value of x is minus 7, therefore x is equal to minus 7. This question, like previous question, can also be done by another method, and you will see that method on part 2 of sequencing series. To another example, example 4, you can see formula 1. It's written in elaborated way. It's expanded form of the formula 1. And example 4, the question is very similar, technique is very similar, but it looks different with this gap between first second and second last and last term. But technique and idea is same. And you can see the solution here. And t1 is 10. This is the first term, t1. T1, you can see second term, T2, and you can see last term, that is second last term. If last term is Tn, then second last term is Tn minus 1, and you can see last term Tn also. Last term is Tn, not Tn. And as in elaborated form and expanded form, we can see this is also D, isn't it? This is also the value of D. And for first two term also, there is D. That is D. We have to use this concept, as D can be calculated by using any two conjugative terms. On any sequence, we can calculate the value of D by taking two conjugative terms from anywhere. You can not only first and second, you can take last and second last term also. Common difference D is equal to T2 minus T1. We have applied the value of you can see this is the T2 and this is T1. Now let's see again. Common difference D is equal to C. This is also the formula for common difference, and Tn is 35 and that is 3x and it is 2. We can relate first and second as they both are D, isn't it? They both are D. We can equate them from first and second. X plus 5 minus 10, x plus 5 minus 10 is equal to 35 minus 3x, and we can arrange the like term x plus 3x, and all the numbers will be on right hand side. 35 plus 10 minus 5. The sign will be changed when the values are changed from one side to another side. Or you can see 4x, this addition of 3x plus x, and on the calculation of number it is 40. Or x is equal to 40 by 10. We can cancel this. 4 1 is 4, 14 is 40. It goes by 10. Therefore the value of x is equal to 10. Now, very easy question and very important for sub question, 2 marks question. That is example 5. Oh, try this exercise for you. And first we have to identify that the series or sequence, they are all series, and as uh, arithmetic or not. They are arithmetic or not, you have to identify. And how to identify? You have to check the common difference between the two terms. Now here you can see the difference between the two terms is 2, 2, 2, and we can easily say this is an arithmetic progression. And here, right here, it's not, the gap is not equal or constant. It is not. It's not. You can check in a similar way. You can do as an example one. As an example one. It is a, you can do exactly as an example one. And there is another question also in the same slide. Find the value of unknown variable. You can do it by example 2, 3, whatever it is. You can start with 2, 3, 4. Okay, now you can apply this and you can easily find the value of these variables. Okay, let's move to another slide. To find nth term or last term or general term of arithmetic progression. Now to find nth term, we have found nth term in class 9 also, but here as it is a progression and the nth term will be same, there will be a specific formula to find the nth term. Now let's start. Let t1 is equal to a. The first term from now onwards it will be represented as a. T1 will be represented as a with the first term of the arithmetic sequence, and d is the common difference which I have already denoted it. It's its common difference, and tn be the last term. We have called it last term in previous example also, so it is now verified. It is now official that tn is last term or general term. We can call it last term or general term. Now let's form an arithmetic uh, sequence. Okay, for first term t1 is a. Now what will be the next term? As the difference between the first term and second term is d, we can say our second term is 2 plus d, isn't it? Now the difference, you can see the difference between first term and second term is d. Now what will be the third term? As the difference between second term and third term must be d, our third term will be a plus d, that will be 2d, isn't it? 2d. This is our third term. In similar way, our fourth term will be a plus 3d, because the difference between fourth term and third term must be d. Now here, in all cases, the difference between the term are d. So this is our sequence, and now let's write it. So the sequence in AP is a plus a is the first term, a plus d is second term, a plus 2d is second term, a plus 3d is a plus 2d is third term, a plus 3d is fourth and fifth, and so on. We can find the term. Now let's see, t1 is equal to a. Now that a can be written as a plus 1 minus 1d, isn't it? Now the a 1 minus 1 is 0, 0 into d is 0, so the first term is a. Now it's a, isn't it? Now second term, t2 is equal to a plus d. Our second term is a plus d. Now that can be written as a plus 2 minus 1d, isn't it? Here is 1, the coefficient of d is 1, so 2 minus 1 is also 1. So we can write a plus d as a plus 2 minus 1d. We can write. Now our third term is, now you can see the color, and the color which are in, we can, what in color is it? Let's call it pink. Okay, in the pink color uh, are constant, and the green color are changing, isn't it? The green color is changing. It's 1 in the first term, 2 in the second term, but all other pink color are constant. Now T3, our T3 is a plus 2d, and that can be written as a plus 3 minus 1d, isn't it? 3 minus 1, the value is 2. We have our value 2 right here, so we can write a plus 2d as a plus 3 minus 1d. And similarly, T4 a plus 3d, our T4 is a plus 3d, and we can write a plus 4 minus 1d, isn't it? 4 minus 1, the value is 3, and here is our 3. So we can write a plus 3d as a plus 4 minus 1d. Similarly, t5 equal to a plus 4d, which is equal to, we can write that a plus 5 minus 1. 5 minus 1 is 4, and here is our 4. So we can write a plus 4d as a plus 5 minus 1d. So In similar way, we can continue. And what will be our Tn? Tn, we can write Tn equal to, now what I have said you already in that a plus 1 is in pink color is constant. So it must be a plus 1 minus 1 and d must be same. But what is changing is 1, 2, 3, 4. In green color it is changing. See 1, 2, 3, 4 and 5. And the relation between these two is equal. Isn't it? Where there is 5 it is 5. Where there is 4 it is 4. Where there is 3 it is 3. Where there is 2 it is 2. Then where there is n it must be n. Now what is the formula to find the Tn? The formula is a plus n minus 1d. So that is our last term. That is our general term. And that is the formula. And our formula wall will get populated now. It has a new member in our formula one. That is, you can see the first F2 is L equal to Tn equal to a plus n minus 1d. Now you will see these two formulas throughout the video. So hope you understood this. Example 1a. You can see the formula. There are two formulas right now. Example 1a. Find the common difference d, general term Tn. We have the formula for general term Tn equal to a plus n minus 1d, and 10th term of the sequence. The sequence is given. You can see the sequence 1 by 3. It's in the fraction form, minus 8 by 3 minus 17 by 3. Now we know that this is the first term, this is the second term, and this is the third term. Now here T1 is equal to, T1 is called a, is equal to minus, it is equal to 1 by 3, not minus 1 by 3, only 1 by 3. T2 is equal to minus 8 by 3. We don't need third term, so we need common difference. Common difference, we know the formula, that is F1. Now you can see the F1 formula, d is equal to T2 minus T1. T2, value of T2 is minus 8 by 3 and the value of T1 is 1 by 3. On calculation you have calculator, that is minus 3. Now we have found the value of d, therefore d is equal to minus 3. The first part is clear. And general term Tn. General term Tn is equal to, we have a formula a plus n minus 1d, where we have to substitute the value of a as 1 by 3, and we don't have the value of n, so leave it, and the value of d is minus 3. Okay, now on simplification, 1 by 3 minus 3n, while multiplying minus 3 and n, and plus 3. Now we can do calculation on these two constant terms, these two numbers. Calculation will be 10 by 3. You can use your calculator. 1 by 3 plus 3 minus 3n. And further I'm taking LCM, that is 10 minus 9n. Well, 3 multiplies with 3, it will be 9n. Now this is our general term. Now Tn is equal to 10 minus 9n by 3. Now always remember, the general term contains the variable n. So we don't substitute the value of n. You may substitute the value of n as 10. Now that will be mistake. Now general term, we have found the general term also. Now we need 10th term. Now when n is equal to 10, now n, it is like function, and all the n of Tn will be replaced by 10. Now we can see 10 minus 9 into 10. 9 into 10, this is the replacement for n upon 3. On calculation, you have to calculator 10 minus 90 by 3. That will be minus 80 by 3. That's our answer. We have found 10 answer. Now this is our answer. D is equal to 10 minus 3. Tn is equal to this. This is a very general question. Now let's move to another topic. Example 1b. Now formula 1 you can see every time. Example 1b. Now this question looks similar, familiar to you. Now we are going to count the dots which we have done in class 9, but we don't have to add one more figure like as we did on class 9. We don't have to add one figure. We deal only with are dots only. So on the solution part, writing the series, it has only one dot, so it is 1 4. Here you can count 7 there is, and here it is 10. So we have to deal only with the dots. We don't have to draw one more pattern here. Here we have our series 1 4 7 and 10. Now first term, second term and third term. T1 is equal to a, it's written a, and its first term is 1, second term is 4. Now we have to find common difference as we did in previous examples. Now 4 minus 1, that is 3. Common difference is 3, therefore d is equal to 3. Now fairly simple. Now general term, the formula is a plus n minus 1. We have to replace a by 1 and d by 3. As general term needs n, we won't replace it, although we don't have value also. 1 plus, while multiplying, 3n minus 3, and on subtraction 3n minus 2. That's our general term, tn equal to 3n minus 2. This is our next answer. This is our first answer, second answer. And when n is equal to 10, now n will be replaced, this n will be replaced by, 10. T10 equal to 3.10. This is the value of n minus, that is 28. That's our answer. Now only we have to do with this figure, only this much we have to do with this figure. In 9th class we just checked it is a linear or quadratic. According to class 9 it is linear. As we studied, this is a linear, first difference is equal. And for linear, what we did is tn is equal to an plus b. We applied that, first difference is a. But here it is a fairly different concept. It is a progression and it has only one formula to find the general term, that is a plus n minus 1 b. Okay, let's move. Now there will be, I think, exercise for, yes, there will be exercise. Try this um, like we did in previous, on previous slide. You can do it easily, and the figure is also there. There is only one figure. You don't have to add any more figure here. Okay, you just have to deal with the counting, only counting dots. How many dots are there? It's 1, and pentagon it's 5, I think, and here 6 7 8 9, and it must be 13, isn't it? So you can easily find general term tn and common difference, general term, and 10th term, number of dots on the 10th term. So let's now formula 1, you can see. Now our example 2 is, we have value of tn is equal to 29 and common difference is, and d is equal to 3. Find the value of a and d 15. We have to find the value of a and 15th term, value of 15th term, and we have to find the first term. Now we have t10. Now if we practice here, the first term is a, isn't it? First term is a. Let's practice here. Second term is a plus d, isn't it? A plus d. Then third term is t3 is a plus 2d, isn't it? Now we can easily say what will be the 10th term, that it must be one less than the number here. The number in front of d must be one less than the number with t, isn't it? Number term. Now that will be t10 is equal to a plus 9d, isn't it? A plus 9d. If we know this, then we can use this directly also. Now you can easily say t30 will be, okay, t38 will be a plus 37, sorry, a plus 37d, 37d. Now if you understand this, then it will be very easy. Now let's start our solution. Here t10 is equal to 29, then the value of n is 10, isn't it? This represents the value of n, that our n is 10. Now common difference, it's given as we know the formula Tn is equal to an minus 1. When n is equal to 10, now the n will be replaced by 10, or T10 is equal to a, we don't have the value of a, so we have the value of n, that is 10 minus 1, and we have the value of d, that is 3. Now we have the value of T10 also, that will be 29. 29 equal to 9d. 9d, isn't it? 3 is d. 3 is d. Now T10 is equal to, you can see, a plus 9d. If you know, you can write it directly. Now 29 is equal to a plus 29 is equal to a plus 27. Now 27 will comes to left hand side. 29 minus 27 is equal to a. Now there will be partition, or 2 is equal to a, and therefore value of a, first term is, our first term is 2. We easily found the value of first term. Now we have to find T15. To find T15, a is equal to, we have a equal to 2, d is equal to 3, and n is equal to 15. We know what is T15, a plus, we can guess T15, a plus 14d, isn't it? We can write, if you know, then you can write directly also, that is T15. Now we know Tn is equal to, that's the general term formula. Now T15, n will be replaced by 15, a will be replaced by 2, n will be replaced by 15, and d will be replaced by 3. Putting the value, or 2 plus 14d, isn't it? 14d, this is the d. We can write directly, we can omit this step if we know. Then 2 plus 42, the value will be 44, and T15 is 44. Therefore T15 is 44. This is our answer. Now let's move to another example. Example 3. This is a simple example. Example 3. A similar sort of example here, but we have to find the value of d. In previous example, we found the value of a, but right now we have to find the value of d. A solution here. Now what will be the T15? A plus 14d, isn't it? The T15 will be a plus 14d. Now remember this. Here T15 is equal to 8, 4 by 4. Now on mixed fraction, we have to change to improper fraction, that is 44 over 4. And here it is 15, that means value of n is 15. Now first term is 4 by 5. We have to find the value of d and T8. Same way we are going to do. Now we know Tn is equal to a plus n minus 1d. That is our formula to find the general term. Now when n is equal to 15, n will be replaced by 15, and a will be replaced by 4 by 5, and n will be replaced by 15, and d, we don't have the value of d, so d is written as it is. And we can see T15 is 44 by 5. T15 is 444 5. That is 4 by 5 is the value of a plus 14d. Now these two terms will be together. 44 by 5 minus 4 by 5, which will be equal to 14d. I think it's clear up to here. Now I'm taking LCM, it will be 8. You can use your calculator and find this value directly. That will be 8. And on cancellation, we can see it's, if we divide by 2, that will be 4, and if we divide by 2, that will be 7. Now value of d will be 4 by 7. Now there is a partition, or 4 by 7 is equal to d. 4 by 7 is equal to d. Therefore d is equal to 4 by 7. We easily found the value of d. Now our task is to find T8, that always will be a plus 7d. A plus 7d. T8 is a plus 7d. Now to find T8, and now we have the value of a is equal to 4 by 5. We have the value of d is equal to 4 by 7, and we just found here, and value of n. Now T8 means this is the value of n, and that is value of n. Now we know that here you can write we know, and directly T8 is equal to a plus 7d. Okay, it will be very easier for you. You can write directly this one, T8 equal to a plus 7d. Now or T8 is equal to, n is replaced by 8, a is replaced by 4 by 5, n is replaced by 8, and d will be replaced by 7 by 4. You can see 4 by 7, sorry. Now you can use your calculator, and that is 4 by 5 plus 7 into 4 by 7. We can cancel 7 and 7, and now the sum total will be 24 by 5. Now that's the T8. T8 is equal to 24 by 5. In mixed fraction also we can write that is 4 by 5. This is our answer. Now I think you will get exercise. Try this. Plus, you can follow the previous examples and you can easily do these questions. You can see the question one by one. Question of its common difference is this. Find the first term. We have to find the A. That means example, it is similar to example 1. And common difference, it is similar to example 2, 1 and 2. Okay. T5 is given, A is given. You can easily find everything. That is example is very, very important. Example 4. Okay, let's start example 4. You can see the question on your screen, and formula is there ready for us. And there is something for you. This question can also be asked, as you can see how this question will be asked. It is a one way of asking the question in this way, and you can see there are various ways how this question is asked. Is 23 or term of a series this? It can be asked in this way also. And which term of the series is minus 23? Which term of the series is minus 23? This is the second way of asking. This is, I think, third way. Third way is actually find the nth term of the series. If the nth term of the series is Tn, now see, nth term is given, and we have to find the value of n. Does this belongs to this? The question can be asked in these many ways. Okay, these are 5 ways of asking question. 4 are here, and 1 is in your question. There are 5 ways a single question can be asked. Now, but the method, the way, the procedure will be same for all 5 ways. Here, in first term T1 is equal to 7. Second term is 5 1 by 2. In mixed, it is in proper fraction, it is 11 by 2. And we can easily find the common difference. We have the formula D is equal to T2 minus T1, and you can see it is 11 by 2 minus 7, and that value is minus 3 by 2. Okay, now this is the value of D. And now last term, we have our last term Tn. We can call it Tn also, we can call it the last term also. This 23 can be called as L, and it also can be called, the formula is same, isn't it? So L is equal to, we know the formula. We have L is equal to, A plus n minus 1d. We have the value of A, we have the value of D, and we don't have the value of n. We have to find the value of n. Now you can see the solution. You can see, or 23, value of L is 23 plus A is 7 plus n minus 1, and D is minus 3 by 2. Minus 3 by 2. Isn't it? Now the, or minus 23, 7 plus, you can see the calculation is rolling on your screen. Multiplying this, minus 3 by 2, or that is 30 is equal to minus 3 and minus 1 by 2. Of the cancellation, you can see on the screen, minus and minus are cancelled, and 3 1 ja 3 10 ja 30. Now multiplying 10 and 2 on cross multiplication, that will be equal to n minus 1. Now 20 plus 1 will is equal to n, and 21 is equal to n. The value of n must always be a whole number. Okay, It's 21. It must not be fraction, it must not be decimal. Now, why I said this is, you can see question number 4 here. Question 4: does minus 23 belong to the series? To check it, the value of n must be like this. It must be a whole number. Okay, it must be. It must not be fraction. It must not. Yes, there is exercise. Try these questions. They are very simple questions. They all belongs to the previous example. You can do exactly in the same way as we did our previous example. Now let's see. Move to slide 23. Next slide. 37 slides. Now this is 23rd slide. And example 5, a very important example. And if the third and 13th term, now what is third term? As we can recall, T3 is equal to a plus 2d, isn't it? A plus 2d. So it will be very easy if we remember T3 is a plus 2d and T13 is a plus 2ld. T13 is equal to a plus 2ld. If you like, you can apply this directly. So, now which term is 28? It is that first we have to find the value of a and b, then we have to find the value of n. Solution here, T3 means n value of n is 3. Now n is 3, you can see T3 is 40, value of n is, and T13 is equal to 0, and then n is equal to 13. So n is equal to 13, and we have the formula for general term. Tn is equal to a plus n minus 1 d. When n is equal to 3, and T3 n is replaced by 3, a plus 3 minus 1 d, and which is equal to value of T3. The third term is 40. So value of a, we don't have the value of a and b. So see, you can see a plus 2d, a plus 2d. That's the third term, isn't it? Now you can omit all these steps and you can directly write this T3. We know T3 is equal to a plus 2d, and you can replace the value of T3 as 40. 40 is equal to a plus 2d, and you can write this as equation 1. 40 minus 2d is equal to a, that is equation 1. Okay, you can do this again. Now let's see the partition. There is a partition, and again when n is equal to 13, now n will be replaced by 13, and on this formula, okay, on this formula n will be replaced by 13. T13, you can see 13 is equal to a, we don't have the value of a, the value of n is 13 minus 1, and we don't have the value of 2, and we can directly write T13 is equal to a plus 2d also, and we can substitute the value of T13 at 0. 0 is equal to a plus 2ld. Okay, our time will be saved, isn't it? Process will be short. Now putting the value of a from equation 1, we can put the value of a from equation 1, that is 40 minus 2d. Instead of a, we can write 40 minus 2d. You can see on your screen 0 equal to, on bracket, 40 minus 2d plus 2ld. Now we can open the bracket, or 0 is equal to 40 minus 2d plus 2ld. 0 is equal to 40 plus 10d. Now we can find the value of d minus 40. 40 changes its side, that is 0 and 0 can be cancelled. 0 and 0 is cancelled, so d is equal to minus 4. Now we can find the value of a by putting the value of d right here, isn't it? Here. Now see, putting the value of d on equation 1. Equation 1, we can put the value of d, and we get, or 40 minus 2 into minus 4. The value of d is minus 4 equal to a. You can see 40 plus, and that will be 48. 40 plus 8, 48 equal to a. Now we have found d, we have found a also. We can easily find which term is T28. Which term is 28? Actually, 28, we have to find the value of n here. Now, let Tn is equal to, let us suppose Tn to be 28. We know the formula of Tn. We know the formula of Tn, which is Tn equal to a plus n, or 28 equal to, we can substitute the value of a. Now this is Tn, as you can see we have supposed here, and this is the value of a, and value of n we have to find, and value of d is, it is asked which term is 28. Which term does 28 represent? Or we can say, does 28 belongs to the given sequence? The question can be asked like that also. Or 28 minus 52 is equal to minus 4n, or minus 24 is equal to minus 4n. We can cancel minus and minus on both sides, and we can cancel 4 and 4 for 6, and then the value of n will be 6. It is 6 term. N is equal to 6. So we can conclude by therefore writing, therefore 28 is 6 term. 6 term is 28, or 28 belongs to 6 term. Now this is important question, and you can see it is done easily. Now there is another question before exercise, example 6. If the 6th and 17th term of an arithmetic sequence is 19 and 14, it is like previous. It is like previous example, and find the value of difference only is in both examples is, and that where we have to find which term is 28 in that example. Here we have to find t100. Now let's proceed. We will go really quickly here. T6 is equal to 19 and n is equal to 6. We can easily distinguish this, and value of n is this part. Whatever number is this, that is the value of n. And T17 is equal to 0 is given at T17, and n is equal to 17. And we know same procedure, and we know the formula for general term, a plus n minus 1d. And when n is equal to 6, now we substitute n and 6, then T6 is equal to a plus 5d. It will be a plus 5d. You can write directly also. You can write directly a plus 5d. Now T6 it's given as 19. 19 is equal to a plus 5d. Now 5d will come to left hand side. 19 minus 5d is equal to a, and it is equation 1. It's exactly similar to the previous example. Now partition, and again when n is equal to 17, now T17 is equal to, we can write directly a plus 16d. Okay, now 17 minus 1, you can write 17, value of T17 is, that's 0 a plus 16d. You can write directly T17 is equal to a plus 16d, and then you can substitute the value of T17 as 41. Now we can put the value of a from here, right here. 19 minus 5d is the value of a. We can use it putting the value of a from equation 1. Oh, there is a mistake. T17 is 41, isn't it? We have to write 41 right here. It's not 0, it's 41. Okay. Now, our solution is correct, but here it was a mistake. And now we have corrected it. Or 41 is equal to 19 minus 5d plus 16d. We can subtract there. 41 minus 19 is equal to 11d, that is 22 is equal to 11d. We can cancel it. 11 1 is 11, 11 2 is 22. So value of d will be, our value of d will be 2. Now putting the value of d right here on equation 1, what we can get is value of a. Or 19 minus, that is a value of d right here. It's the value of d. 2 is, now 19 minus 10 is 9. Now there is a partition. Now when n is equal to 100, now we can substitute the value of a, d and n. Then t100 equal to, we know that's the formula of tn. T100 equal to a plus, we can directly write 99d. Then we can substitute the value, that will be 207. That is 207. Therefore T100 equal to 207. These two questions are comparatively very similar. Only slight difference is there. Okay, there will be exercise for you. Try this. There are three questions. You can do in exactly similar way. Just repeat the process. Slide 26, example 7, and this is very interesting and important question also. In any arithmetic sequence, this is the given condition, and we have to find the value of t14. Let's practice. Now this part we must have done on way ahead. Okay, we did it right here. Now, what is ta? That is a plus 7b. Okay, so this practice we must have done uh, some some slide before. But now another question, what is T19? That will be 18, as we have already practiced 18D, and T26, that is A plus 25D, isn't it? And T9, that will be A plus 8D, and T5, that must be A plus 4D, and T14, that must be A plus 3D. Okay, how this begin? Now let's check only one question. T26. T26 is equal to, what we have to do is A plus 26 minus 1, isn't it? This is our formula, n minus 1d. The value of n is 26. That will be d, and that this will be a plus 25d. So what is the relation between these two numbers? You can see there is a difference of 1. When there is 26, there will be 25. So you can easily guess any number. What will be T108? 108. You can easily guess it will be a plus. It will be a plus 107. A plus 107. It will be 1. So we have now we can directly write T5 equal to a plus 4d. See, T5 is equal to a plus 4d, and we can write T9 equal to a plus 8d. As we have T5 here and as we have T9 here, we can write those values directly. T5 as a plus 4d and T9 as a plus 8d. According to question, T5 T5 equal to 9, T9, or we can substitute the value of T5 as a plus 4d and T9 as a plus 8d, and on multiply 5a plus 20d and 9a plus 72. Like term will be together, I think, or 0 is equal to 9a minus 5a plus 72d minus 20d. This from here, all terms goes to right hand side. Now, or you can see 0 is equal to 4a plus 52d. 4a plus 52d. On subtraction, you can see this is 4a and this is 52d. And while taking common 4, bracket a plus 13d, a plus 13d. Now we can write a plus 13d as 4 is not equal to 0. 4 is not equal to 0. So the next part, a minus 13d must be 0. Now, what is a plus 13d? A plus 13d is t14, isn't it? A plus 13d is t14. We can directly write 0 is equal to t14. 0 is equal to t14. So that is our answer. There is one question for you. You can see on the same slide. Try this. In an arithmetic sequence, if tn, you have to do in a same way, exactly same way. T7 is equal to T7 by T11 is equal to 11 by 7. Then we have to find the value of T18. You can easily do this question. Example 8. Now, formula valve, you can see. Now the question is on your screen. Same question. It is given on word problem as a word problem. It's written in a language form. Let's see. 10 times the 10th term. 10 times the 10th term. T10 is equal to 15 times. Same question. Exactly previous question. Like 15. Then first term is also given here. A slight difference is there. A is given, and we have to find the common difference D of the given arithmetic progression. Now first term is A is equal to 48, and according to question we can write of 10 times T10 is equal to 15 times T5, and as we know T10 is, we can directly write or 10 bracket A plus 90. We know T10 is A plus 90, and we know T15 is A plus 14D, isn't it? Yes. Now on multiplication, 10A plus 90D is equal to 15A plus 210D. Multiplication of 15 and 14 is 210D. I think this step is clear. And now we're writing the value of A. We have the value of A, so we can write the value of A as 48. 15 into 48. This is the value of A. Replacement value of A. This is the value of A. Now we can easily find the value of D, because only the unknown variable remaining is D, isn't it? Now 480 plus 90D, and everything is on right hand side, only 720 is left hand side, and you can see this is a calculation. Okay, we can run through these calculations, and we can see 0 and 0 got cancelled, and we can cancel this is by minus 2. Now we can cancel this. Now D value of D is minus 2, or D is equal to minus 2. So therefore D is equal to minus 2. Now there is one question for you, exactly similar type of question, exactly same way of doing the question. You can see on the screen 7 times third term is equal to 2 times fifth term, and its common difference is 5. Now here common difference is given, and you have to find the value of A first term. Now very important question, very important for 4 marks question. This is 4 marks question. For 4 marks it is very important. You can see the question, the 3 terms of AP. This question can be done on third part of sequential series, but I prefer to do it in first part. This can be done on, because sum we haven't studied about the sum right now, but this sum, and as we are not going to apply the formula, as we are going to apply the logic, so this can be done in first part also. This question can also be asked as divide or split 21 into 3 parts, such that parts which are in AS arithmetic sequence or series, which product is 350. Now you can ask this question. Question can be asked in this ways. Okay, now this is very easy, and let's start the solution. In this type of question, we generally suppose 3 terms in arithmetic progression, A minus D. Remember this, and A minus D, A and A plus D. If it is written like this, if the question is asked in this way, and if 3 terms are in AP, if the sum is this, product is this, then you have to suppose the 3 terms, because it will be easier to get the solution. If we can really quickly find the solution. Now A minus D, A and A plus D, these 3 terms are in arithmetic progression, because you can see the common difference is D. Common difference between the 3 consecutive terms are D. And now let same thing, we are going to suppose it's a solution part. This box is understanding part only, for understanding purpose. You don't have to write on your copy. You can start from here. Let 3 consecutive terms in AP be A minus D, A and A plus D. Now case 1, the sum is 21, isn't it? Case 1, sum of 3 terms is equal to 21. So we can write 3 terms, or A plus A minus D. It's in green, and this is what we call this one. Okay, whatever call it, it's blue. A plus D is equal to 21. We can cancel D and D. You can see D and D is cancelled. Why we supposed? I think you understood now, because we can cancel it. Now 3A equal to 21. So A is equal to 7. We found the value of A, and now let's apply the second case, case 2. Product of 3 terms is 315. Now you can see on the bracket A minus D dot A plus D is equal to 315. Now product means the multiplication of 3 terms will be 350. Sum is 21, product is, now we can substitute the value of A. we can use the value of a. 7 minus d, the value of a is dot 7, and we can cancel this 7 and 315, this 7 which is in multiplication form. See, 7 1 to 7 and 7 45, yeah, it's 45 times 350. Now we can say this is a plus b, a minus b. If you have forgotten the formula, that is a square minus b square. 7 square is 49 and d square, isn't it? It's 49 minus, this is a plus b, here you can see a plus b, and a minus b. The formula is a minus b. Now that formula is a square minus b square. A square minus b square. Now a is 7, so that is 49, and b is d, that is d square. Okay, hope you understood it. And now number on the same side, 49 minus 45 is equal to d square, and or 4 equal to d square. 4 can be written as plus minus 2 square, isn't it? Plus 2, square of plus 2 is also 4, and square of minus 2 is also 4. So we have to write both plus and minus. So value of d will be plus minus 2. D is equal to plus minus 2. Now there will be 6 answers because of the plus and minus. When a is equal to 7 and d is equal to 2, a minus d, we have to find all 3 terms. Means 7 minus 2 is 5. A is equal to 7. A plus d is equal to 7 plus 2. That is 9. And another when a is equal to 7 and d is equal to minus 2, we have 2d, isn't it? Value of d is plus 2 and minus 2. Both we have to apply both. Here we have 2 value for d, plus 2 and minus 2, plus 2 and the minus 2. We have to apply this both the value and find the answer. Now when a minus d will be equal to, a is 7, and as there is minus sign, we have to use brackets, so 7 plus 2 is 9, and a is equal to 7 and a plus d, 7 plus bracket minus 2, that is 7 minus 2 is 5. Now our answer, hence the numbers are 579, 579 or 7 or 579 or 975. There are 6 answers, 6 numbers. Now there will be exercise for you. Exactly same way. There are 4 questions. Same way, same style, same way. Let's move to slide, I think 30. Example 10. A similar type of question, but condition, second condition is slightly different. Now you can see first condition is same. First condition is same, sum of 3 number in A is 2, but second condition, sum of the square is 52. Second condition is a little bit different. You can see this in this type of question, which will suppose 3 terms in APB, and suppose 3 terms. Case 1, sum of the terms is equal to 12, as you saw in the previous slide. A minus d plus a minus d. You can see a minus d, a, and a plus d is equal to 12. We can cancel d and d, that is 3a is equal to 12, and a value of a is 4. Value of a is 3 1 3, 3 4 12. Now value of a is 4. We have found the value of a like in previous question. Now the case 2 is a little bit different. Sum of the square, their square, we have to add them, but we have to add them by squaring them. Now you can see a minus d whole square plus a square plus a plus d whole square. We have to add them, but by doing square is equal to 56. Now we have to open the formula. You can see the formula, a minus b and a plus b whole square. The formula of a minus b and a plus b whole square is there, right there. Now let's open it. Or a square minus, let's substitute the value of a, then we can open it. Or 4 plus d, then we can open it. Now a is 4, that is 4 square minus 2ab. You can see very clearly 2 dot 4 dot a, this is ab, and b square, this is b square. Again for this part, it is 4 square, it is right here, and for this part this is a square plus 2ab and b square, which is equal to 56. Now there is only one variable, so we can easily find the value of d. or 16 minus 8d plus d square plus 16 and 16 plus 8d plus d square is equal to 56. Now we can cancel 8d and 8d, and all the 36, the sum of the 36 316 will be 48, or 2d equal square is equal to 56 minus 48, or 2d square is equal to uh, 8, and d square is equal to 4. Like in previous question, 4 can be written as plus minus 2 square, as the square of positive 2 is also 4 and the square of negative 2 is also 4. Now value of d is plus and minus 2, which is equal to plus 2 and minus 2. There will be 6 answers. So when a is equal to 4 and d is equal to 2, a minus d is equal to 4 minus 2, that is 2. A is equal to 4, a plus d is equal to, these are the terms which we have supposed in the beginning of the question. So we have to find those values and partition. And when a is equal to 4 and d is equal to minus 2, as we did with this plus 2, and we have to do with this minus 2 also. Now there is some minus sign, so we have to apply the bracket here, and that will be 6. And a is equal to 4, and a plus d is equal to 4 plus minus 2. That will be 4 minus 2, that is 2. Hence the numbers are 4, 6, 4, 2 and 2, 4, 6. If you pay attention and if you are careful in this part, then you can easily get the desired answer. Try these questions. There are 2 questions and you have to do it in this exactly same way. Example 11. First, the sum of the first 3 terms of AP is 21. The sum of the first 2 terms is subtracted from the third term. The first condition is same like in previous example, but second condition is different. Here we have to find the terms. In this type of question, we generally suppose the 3 terms in AP to be a minus d, a and a plus d. Let the 3 consecutive terms in AP be this, as we have supposed this. Now case 1 is same. The case 1 is same. Sum of the 3 terms is 21. You can easily find the value of a from here. D and D is cancelled, so a value of 3a. D and D is cancelled. 3 is equal to 21 and value of a is 7. Now in second case, T3. Now read the question again. First 2 terms, sum of first 2 terms means T1 plus T2 is subtracted from third term. Means the from part must be in front. So this is our condition, isn't it? Sum of first 2 term, that is sum of first 2 term, T1 and T2, sum of first 2 term is subtracted from third term. The from part must be which you have learned in algebra in junior classes. Now we have to replace the value. T3 is a plus d, a plus d is T3, a is T2, and a minus d is T1. This is T1 and this is T2. Generally we have learned that a is T1, but in this case it is T2 and T3. Now see, T3 is a plus d, T1 is a minus d, and T2 is a. Now we can open the bracket and we can easily find the value of d. It's just it is difficult to arrange the condition, to put the condition in a correct way. That is difficult, and after that it will be very easy. Seven minus d plus 7, that bracket is equal to 9, or 7 plus d is equal to minus 7 plus d minus 7 is equal to 9. And we can cancel 1 7 right here. 7 and 7 get cancelled. Or 2d. Now this is the calculation. We can just run through it. Now value of d is 8. Now value of d is only one single value is this, so there will be only three answers. A minus d is 7 minus 8. This is very simple, so we run through it. Hence the numbers are minus 1, 7 and 15. These are the numbers, and there is exercise for you in the same slide. You can see two questions are there. You have to do in same way, exactly same way. Okay, there is answer for you also. Now example 12. If the nth term of a series and nth term of series, there are two series and nth term of both series as according to the question are equal, so we have to find the value of n. So let's find the nth term of this series first and then this series, then we can equate it because according to question they are equal, and we can easily find the value of n. Let's solution for series, 14 plus 12 plus 10 dot 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 infinite series. It is, we have first term a is equal to t1 is equal to 14 and t2 is 12. Common and t2 second term is 12 and common difference t2 minus t1, that is 12 minus 14, which is minus 2. Now we know the formula to find the general term. You can see in the formula well also, tn is equal to a plus n minus 1d. We have the value of a, we can substitute it. We don't have the value of n, we can have the value of d. And here we can substitute the value of d on multiplication minus 2n plus 2, that will be 16 minus 2n. Now this is equation 1. And now we'll see the partition. And for another series, we have to proceed in the same way. First term t1, t2 is equal to 17, common difference is equal to 17 minus 20, that is minus 3. And we know we have the formula for general term, tn is equal to a, value of a is 20, we can see here, and value of d is minus 3. This is applied, and on while opening bracket minus 3n because of this minus sign, and plus 3, minus into minus is plus, so 23 minus 3n. Now according to the question, this 1 and this equation 2, they are equal, isn't it? The general term, they are the general term for series first and series 2. Now, from 1 and 2 we can equate that those general terms. 16 minus 2n is equal to 23 minus 3n, and like term on same side, 3n minus 2n is equal to 23 minus 16, or n is equal to 7. Now that's the answer, n is equal to 7. What we have to do is we have to find the general term of first series, and we have to find the general term of second series, and as according to the question they are equal, so we have to equate it and we can easily find the value of n. Now there is question for you, and there are two questions. You can try these questions and you can do it in the same way, exactly same way. Now let's move forward. Example 13. You can see the question is a different type of question. Example 13. Let's see the different type of question. For AP, general term is A. Why capital A is written? Because already small a is present on the question. It's here in the question. So to avoid the confusion, any sort of confusion, we have written capital A. An explanation is there for you. Note, a capital A is used in the formula of Tn because small a is already used by question. Question has already used, so we have to use capital A, and that won't make any difference. Okay, and now when n is equal to p, Now you can see the pth term of AP is A. Now when pth term means like second term, the number is 2, value of n is 2. So value of n will be P. For pth term and value of n is P. Now we can replace the n, this n, you can see this n by P. Now A, first term is A, isn't it? First term is A. Now pth term is A. So TP will be replaced by A. TP will be replaced by A. Now, similarly, when n is equal to Q, TQ is A plus Q minus 1 and TQ will be replaced by B. Now you can see Qth term is B and Rth term is C. So TC will be, TR will be replaced by C. The value of TR is C. The value of TR is C and value of TQ is B. TQ is B. Now these P, Q, R are the value of n. P, Q, and R are the value of n. We will replace n by P, Q, R. And similarly, when n is equal to R, TR is equal to capital A plus R minus 1D, value of n is R. So TR is equal to C. Now let's subtract B and C because it's in the question. Okay, we don't do things randomly because it's in the question. B minus C is equal to the value of B is, you can see the value of B right here, A plus QD minus D, and the value of C is A plus RD minus D. Now let's open the bracket. A plus QD minus D minus A minus RD plus D. Now what we see here is D and D is cancelled, capital A and capital are cancelled. So the remaining is QD minus RD. Now again C minus A. Now what we have to do is C minus A. Again C minus A. Now we can put the value of C right here. A plus RD minus D and minus value of A, you can see right here, A plus PD minus D. Now let's open the bracket and we can cancel few terms, RD minus D minus A minus PD plus D. Now D and D is cancelled and the first term A and A is cancelled. So the remaining is RD minus PD. Now again we have to find A minus B. Also A minus B. Now we have the value of A right here. It's the value of A. We can substitute the value of A. Now again we have the value of B also. You can see here it's the value of B. And we can open the bracket so that we can cancel few terms. PD minus D minus A minus QD plus D. Or A is cancelled. You can see A is cancelled. And D is also cancelled. Now left hand side, let's see left hand side, P times B minus C, Q times C minus A, R times A minus B. Now left hand side is P times, now we can replace the value of B minus C as QD minus RD, and we can replace the value of C minus A as RD minus PD. We can replace the value of A minus B as PD minus QD. Now we can open the bracket, PQD minus PRD on multiplication, QRD minus PQD plus PRD minus QRD. QRD is cancelled, PRD is cancelled, and this is cancelled, and then our right hand side is 0, which is right hand side. Nice. If we follow the steps properly, it's very easy question. Application of arithmetic sequence, arithmetic progression. You can see the formula on formula 1. Now, the question looks like monthly salary of a person is this. 40,000 is the monthly salary. It increases every year by this. If we understand what this value represents, then we can easily find. We can easily solve this question. This is very easy question. Monthly salary, we can say this is the initial salary A. And every year it increases by 2000, means it is D, and T11 we have to find T11. Now see, we have the value of A, we have the value of D, we can easily find the value of T11 as this is N, isn't it? Now let's write the sequence. The sequence is 40,000. In first month it is 40,000, first month of first year, and first month of second year it will be 42,000, and first month of third year it will be 42,000, and so on. Now here the value of first term A is 40,000, second term is 42,000, or we can directly write common difference is 2,000 without writing second terms. Without writing this, we can skip this step. Second difference. We have the formula of Tn equal to A plus n minus 1d, where n is equal to 11. We can substitute the value of n as 11, or T11 is equal to 40,000. That's the value of A. 40,000 is the value of A. It's the value of n, and it's the value of d. And on calculation, we can easily find, this is the calculation part, that's 60,000. On the 11th year, first month of the 11th year, a month of increment, on that increment, appraisal month, you can say, where appraisal is done, and the salary will be 60,000. Now similar type of question is given for you. Now initial taxi fare for traveling a taxi is 5. That means the value of A is now A is equal to 5 first, and we can see increases means this is the value of D, and the value how much to pay to travel 10 kilometer means T10. We have to find the value of 10, where n is equal to n is 10. So we can easily do this question. You can easily do this question. Okay, let's move to another practical question. Example 50. Formula 1 is there. The salary of an officer in a finance company is noticed as the starting salary per month is 6,000, and this you can easily say this is A, and increases, this you can say it is D, but increases in a different way as in a 6 month, and it means it increases twice in a year. It increases by 800 per year. You can assume like that also, uh, or you can say you can multiply the time by 2, or you can say it is by 2. You can go by 10 half years. Let's see. Writing the sequence. Initial salary is 6,000. After 6 months, it will be 6,400. After another 6 months, it will be 6,800. Now the first term here, the first term is A, and second term is common difference. We can easily write. Now we have when n is equal to 5 into 2 plus 1. Now why this is done, and this thing you have to understand. Now, why it is done 5 into 2 plus 1. Why plus 1 is if we take 64,000 as initial salary, 6,400 as initial salary, then we don't have to add this, but we are taking 6,000 as A, we have to add 1, because in a year, in the first suppose first of Baisakh, it is 6,000. Then after 6 months means Baishakh Jet Asar Sound or the Asaj. In Asaj, first of Asar, the 6,400. So in a single year, the salary is thrice, 3 times the salary. You can see the salary. There are 3 different salary in a year. In a single year, there is it starts with 6,000, then 6,400, and then 6,800, and 6,800. So add 800. So we have to add 1. Or if we take this 6,400 as A, then we don't have to add 1. Now there is explanation for you why, and explanation of why is there. If we assume salary on the January 1st is 6,000, then on 1st July, after 6 months, it becomes 6,400, and at the end of the year, the salary becomes 6,800. Salary increases twice a year, so in 5 years, it increases 10 times. So that's why we multiplied by 2, isn't it? So if we consider 6,000 as the initial salary, then total will be 11. Now if we include the 6,000 as the initial salary, then it will be 11. There will be different salary in 11 times. Okay, there will be 11 different salary on a sequence. There will be 11 terms. Okay, if we consider 6,000 as a initial salary, there will be 11 terms on a sequence. If we consider 6,400 as an initial salary, there will be 10 terms. So it depends on you. Okay, then total will be 11. If we consider 6,400 as initial salary, then it will be 10. So hope you understood this. Now T10 is equal to, we know the formula, and value of n is T10. It must be T11. Okay, in 5 years. So we are T10 is written because it is 5 years. Okay, it is for 5 years. So we can write 10. We can write T10 also. Okay, don't worry about it. Or you can correct it as 11 also. It doesn't matter. 6,000 plus 10 into 4,400. Sorry, and now that salary will be rupees 10,000, and therefore his the last salary per month after 5 years. Last salary per month after 5 years will be 10. That will be 11th salary. Okay, that will be 11th salary. If we construct a sequence here, then there will be 11 months. If we start with 6,000, there will be definitely there will be 11 months, because this is the initial salary and this is the salary on the first year, isn't it? Now there will be on for 5 different years there will be 10, and if we consider 6,000 as the initial salary, there the value will be 11. So this is the way to understand it, and so we finally concluded our entire topic. Thank you for being with me. And if you found this useful for you, it will be useful for your friend studying on the same class. So you can share with them. Thank you for being with me once again, and see you on part 2 of sequences series. And that will be arithmetic mean. And we are going to study about the arithmetic mean. See you on part 2.